Really? Okay. Yeah, could you just start off by introducing yourself and telling us what it is that you're doing at the moment from a study point of view?
I'm Dr. JIAJUN Wu, and I'm now studying in Bremerhaven, and I'm a postdoc researcher at the Alfred Wegener Institute. I'm now doing Earth system modeling study about a marine-based carbon dioxide removal approach using microalgae.
Okay. A little bit more about yourself. Where are you from? Why you came here? What attracted you here?
Originally, I came from China, and I did my master and PhD at Kiel at GeoMar, and now I moved to Bremerhaven for my postdoc. Well, what should I just say more? Or?
Oh no, that's good. That's fine.
Okay,
yeah.
All right.
So what got you interested in the subject that you study? What was it that made you want to study what you study?
My background is marine biology and biological oceanography, and I found it's one of the best solutions to mitigate climate change is to find natural-based solutions in the ocean. That's why in my PhD study, I did modeling study about using microalgae for carbon dioxide removal. It's analyze and assessment using the Earth system model, and so that drove me to the area of climate change mitigation.
So to just get a bit more personal though, what are your thoughts about the climate? I mean, are you concerned about where we're at and where it looks like we're headed?
Definitely, we are moving to a very dynamic and let's say dangerous era that climate change is happening, and due to the releasing of greenhouse gases, especially carbon dioxide. And last year is one of the warmest year on record. So we are facing multiple challenges happening and going to happen in the future, like drought, floods, and more extreme climate events happening. So we should look in the future for big pictures and for the future of the human being society.
So the reason that you're involved in basically climate restoration, can you just talk about the fact that, you know, just reducing greenhouse gases is essential, but it's not enough, and so the work that you're doing is about finding ways to actually remove carbon, which is what we have to do.
Yes, of course, in addition to the traditional mitigation approaches like clean energy and reduction in greenhouse gas releasing is not sufficient to achieve net zero at mid of this century, or not to talk about the further net negative scenario. There are always some emission that is hard to abate, and also some very refractory residues of our emissions will be very difficult to abate, to avoid, like the greenhouse gases production from cement production and aviation. So that's why we need carbon dioxide removal approaches, and especially given that many times of failure and insufficient reduction pathway happening now, we probably need CDR approaches in a larger scale and longer time scale in the future. So it's better to start the investigate earlier than later.
Okay, that's been good. When did you first hear about the concept of removal of CO2?
I heard it from the beginning of my PhD study.
Oh, sorry, can you say, I first heard about
I firstly heard about carbon removal when I started my PhD study. There is a project called SPP 1689, led by Andreas Socialist from Geomar. It's about geoengineering, and from that research project I heard removal of carbon dioxide could also be a very critical and important approach to mitigate climate change, because that will solve the problem from the root.
Can you talk about the nature of the modelling that you do? I mean, and explain what modelling is even. It's for a very average person. So, you know, people have an idea of using microalgae and stuff, but you can't just do it, you have to research it, and that's why your work is so important.
Okay, so I'm using do it again.
Yeah, absolutely, no problem.
I'm using numerical model to assess the approach of using microalgae for climate change mitigation or carbon dioxide removal, because well, numerical models are critical tools to research climate change, as we can use the numerical models to predict the future trends of climate change. For instance, most of the IPCC conclusions or their how to say that? The IPCC
projections?
yeah, most of the IPCC projections are based on.
Yeah, okay, now go.
Most of the IPCC projections are based on model assessments. Numerical models or climate models can be validated against the paleo and historical climate change records, and then use the calibrated and validated model to predict our climate in the future. My study using the Earth System Climate Model to assess the microalgae-based carbon dioxide removal approaches is critical because, one, we cannot really carry out this large-scale aquaculture farm for macroalgae in the real world right now. And the second, we have to investigate the potential capacity and side effects of this approach in advance before we apply them in the real world.
So in other words, again, for the average person, we need to know what works about it, but we also need to know what the problems might be.
Yes, before we apply any kind of carbon dioxide removal approaches, we have to thoroughly analyze the capacity and side effects of this approach in many perspectives.
And in the work that you're doing, have you come across any surprises?
During my research, I found that the capacity of macroalgae-based carbon dioxide removal is around several gigatons of carbon dioxide per year if we apply them in the open ocean in the maximum scale. And also, they're one of the surprising results from my output is due to the application of aquafarm in the open ocean on the surface, we reduce the export flux of organic carbon to the middle layer of the ocean, and that relieves the oxygen reduction in the middle layer, which is called the oxygen minimum zones, which is one of the positive benefits from our from the macroalgae-based approach. I think that's it.
Okay.
Yeah.
Sorry, that's a good thing?
But it's very difficult to understand, right?
Yeah.
Yeah.
But so essentially, if you could just say, so essentially that's a kind of a positive outcome? I'm sorry, it's a complicated subject and it's a second language.
Sure. No, well, I'm organizing the sentences to describe that.
I mean, it's the fate of the planet, really.
So. Yeah, no, let me think about it.
Yeah.
if you want to start. Yeah. According to my research results, the capacity of microalgae-based carbon dioxide removal has the capacity to... No, this is not a good sentence. One moment.
No, that's fine. Yeah.
According to my research output, the microalgae-based carbon dioxide removal has a capacity of gigaton scale carbon dioxide per year, and it can be continuously working for at least several decades. One of the other side effects, positive side effects, is the reducing of dissolved organic matter downward flux due to the reduction of primary production on the surface from the phytoplankton, and that release the oxygen reduction level in the mid-ocean. Yeah, that's what I would like to say, the good part of the method.
No, that's good. Just give me one. I don't think we stated the obvious, and that is that you know, the development or use of macroalgae is an effective way to remove carbon dioxide, or one of the ways that can really have an effect.
Macroalgae species are productive photosynthesizers from the ocean. Their growth rate and the carbon content in the biomass is high, makes them a very good carbon carrier in carbon dioxide removal approaches. And also the aquaculture technology and breeding technology of macroalgae species have already been well established. Meanwhile, what I'm studying now is utilizing the pelagic macroalgae species called sargassum. They are self-floating species, which means we don't need special infrastructure for the substrate of the macroalgae to grow. The carbon content of sargassum is also very high, and they fragment and sexual reproduction of sargassum is also very fast. The doubling time of the biomass is around 12 days to 20 days. And also the sargassum bloom is already happening naturally in the North Atlantic, which is called the Great Atlantic Sargassum Belt, as well as in coastal of Yellow Sea close to China. There is also sargassum bloom called the Golden Tide. So that means the sargassum in natural circumstances can already grow in a large scale. And if we artificially enhance the growth of sargassum by using artificial upwelling, which pump up the nutrient-rich deep water to the surface to fertilize the growth of sargassum, and then we harvest the biomass of sargassum and converted them to permanent carbon sequestration products like biochar or bioplastics, then that will achieve the carbon dioxide removal from the atmosphere.
That's great. That's great. What are your thoughts about moving forward? You're just finishing your postdoc. Just mention that you're doing your postdoc at the moment, and then after that you're considering going into consulting, or I mean, what are you considering doing?
I'm now doing my postdoc research, and after my postdoc research, I think I'm open to any possible area to further working on this carbon dioxide removal approaches, like consulting, and I'm also happy to stay in academia if I get funding from any foundations, and yeah, I think this the method of, or the idea of utilizing macroalgae for climate change mitigation is quite promising. Yeah, one of the best solutions on the world, maybe.
And maybe just a little bit about that. This is a growing field of research and hopefully deployment as well. Maybe you see that as this is something that's growing in the future.
Using macroalgae for climate change mitigation is a growing field that many startups has already applying this method in small-scale experiments like CFUs and macrocarbon. Also, this could be a very promising option for the further consideration in climate change mitigation, because this is a natural-based solution, and this is also a very environmental friendly solution if we can manage the application and process correctly and properly. And I think this is a very promising field for further research and investment.
That's great. Oh, what's your personal thoughts about the future? Where do you think we're going to get out of this mess?
As a climate change, as a researcher using climate change model, sorry, this is so messed up.
Okay, hold on.
As a climate change researcher using climate models, I believe that if we take the proper steps in the future, we definitely have the possibility and chance to limit or mitigate the climate change. But if we cannot take action as soon as possible and as deeply as possible, we probably will be missing the window of opportunity very soon. The door is closing, so we should act fast.
Yeah, that's great. Yeah, that's a good way to know.